we have there is 500 mils and another 500 mils of zinc bromide, 1 mole solution, so it's 225.5 grams of zinc bromide in 1 litre, and the pH test of that liquid, I think it's about a 3, so it's alkaline, somewhere between there and there. I don't think that one's a match. It could be a 4, sort of in between those two and those two, more like that one. So all I have to do is fill up the 2 tanks. I'm going to make this one the positive side, the back one the negative side. I've taken out the bolts because they'll shorten the cell out. I didn't pick that up until the other night when I was thinking about setting all this up. I'm going to drive the 2 windscreen wiper motor pumps. Hopefully they work. Oh, they run, but hopefully they pump with the pulse width modulator driven off of the battery. I'll have to connect the charger. Got the data logger and everything set up. No voltage or anything yet because we're not connected. So I'll fill the 2 tanks, put that piece of plastic over all of this so I don't squirt my computer if anything happens. Got a spill tray, and if everything goes well, we'll see what happens. We're running the pumps at 33%. You can sort of see the liquid's coming out the top. Is it coming out of the top of both of them? Yep, I can see some water, liquid electrolyte we should call it. We're leaking pretty badly. Where are we leaking from? The holes. The pipe holes. Alright, that's not good. So let's get this experiment going. I'll just connect the data logger. Okay, the data logger is connected. We got 0.1 of a volt, 0 milliamps flowing through it, so we'll stop the pump. It may need to be pulsed, and we'll see what's happening. Voltage is going up a little bit. No flow of milliamps. I think the cable's all connected. Yep. It may backflow and fill up that tank maybe, and the chamber's emptying. I'm not sure, but we're leaking a lot. So obviously I didn't put enough silicone around the inside of the bolt holes. So I'll increase the voltage. Even that's not going up so quickly. We're at 4 point something, no milliamps flowing. So we maybe failed. Well, 1 tank's empty and 1 tank's full. So maybe one side's not pumping properly. Let's turn on that. We'll increase the speed. Yeah, 1 pump, oh yeah, now the pump's flowing. 1 goes faster than the other, which I thought it might. That's alright, if it doesn't work we can keep the electrolyte anyway and make those layered cell type things. I'm happy with this thing though, it's quite good. Yeah, see, 1 pump's going really fast and the other pump's barely pumping. You can see the air bubbles in that one. No milliamps. And everything connected right. Positive, negative. Yeah, there's a lot of air in that first chamber there. That one's probably not totally full. Let's increase the speed. I think that's that chamber what's, oh yeah, it's coming out through there, but just. There's not a lot of it in there, but you can't hardly see through the plastic. There's a bit of leakage. You can see the flow on that one. Well, that one's the low cell, and that one's got seem to have more liquid in it. So we don't have a lot in there. See, that one's not filling up. It's still fluffy. Let's see if it flows back. See the other chamber? It's much full than the other one for some reason. Maybe the membrane's broken inside. Still no milliamps. No colour change. I might put that one on an angle facing that way so it's pumping more liquid. I'll get back. I just turn the pumps off and the voltage starts to increase. Getting the flow right, and one tank's barely got anything in it. The other tank's filling up, so that would mean liquid's crossing the barrier in there. I would think the membrane could be broken. I did pump some hydrogen through there and lit it, and it exploded. It sort of, I didn't think the hydrogen generator was working. I was just using those two tubs. Just a little bit of stuff in there. And sodium hydroxide. Nearly deafened me. So we're back to 3 volts there. So we turn the pump on. I've set the pumps at 25%. And the voltage starts dropping again. No flow going, so I'll increase the pump. No. What's happening? Oh yeah, we're flowing now. That tank being empty is a worry. That's not helping the situation. I reckon one side's got electrolyte and the other side's empty. Going by the colour of that tube. I got safety glasses on. Need more liquid in that other chamber. I'd say the membrane's broken, surely. They sort of hold up when they're in a separate tub each, that membrane, but it sort of keeps the liquid apart, but something's going on in there. Alright, 0.2 volts, no milliamps or a very fine milliamps. I'll just check the load of the motors, see what they're pulling. I'll be back. Both motors are pulling 0.8. They're in parallel, the motors, positive to positive, negative to negative. Oh, that one's going to run dry. I'll see if I can stop it and stick some liquid back in that one. Alright. Okay. Filled the fuel cell up. Well, that one. Start. I don't think the pumps will blow off. Okay, we have liquid. Got a voltage drop now. That's where the pumps are stopped. Okay, that chamber's holding up a bit better with electrolyte. Alright, we'll stop the motor. It's a very handy feature here. You can just start and stop them. Yeah, I think, look, most of it backflows. You need a one-way valve down there, I think, because the liquid just goes back down. And we go on to 1 point. Oh, we jumped up to 3 volts then. Let's give it another little pump. Yeah, that tank keeps filling up more than that other one. Just slip that under there. Yeah, that's draining that tank. Still draining into the other one. And we'll stop the pump. We're at 0.2 volts. We're still consuming 0.3 amps. That's a greedy little pulse width modulator. Now we're going up in voltage. Whatever's left in the chamber, I guess, is converting. There's no color change. This battery's starting to hiss, so I can hear it. Might stop the experiment because nothing's really going on here. We're just leaking away. So I'll collect my electrolyte, store it, and I'll pull that apart and see what's going on. But I think we need one-way valve at the bottom and fix those holes. And check that membrane before we do anything more. And since it's a flat line with no milliamps going through the cell, I think it's a dirty. Didn't think it would work that well. I thought it would actually have a little bit, but I think because of the liquids going back down the tube and filling up that chamber, we're not going to get anything going across the membrane. Alright, signing out for now. I've just disconnected the power and it's like dropping at 0.049 volts dropping. So there's probably only a fraction of liquid, or not even anything, and it's just the plates being wet and the carbon pad's about there. And there's probably about that much gap before it hits that bottom tube. So all the liquid goes back down. So need one-way valve, need a better membrane, and we have some color change on that membrane there. The silicon was black, so it shouldn't be giving out that color. It's like a little pinky color. We may have got some electrolyte change, perhaps. I'm not sure which one actually changes, the negative or the positive turns to bromide. I can look it up. Okay, well that solves that. Put that to sleep. I'll keep that electrolyte there and make those little flat cells Robert Murray Smith makes. Alright, later date. From this experiment run, I retrieved all of the electrolyte. So we got 1 litre in there. That's a 2 litre vinegar bottle. I think that might be safe enough to do it. Some of the carbon pad dropped off, contaminated it, but I can run that through a filter anyway. So we'll need 2 one-way valves if we're going to pulse the motors, because due to the liquid flow can't be too fast, I'd imagine, or it's not going to send a charge across the 2 cells. Might use a material membrane coated in cellulose acetate instead of the paper towel, and I'll get some nylon nuts eventually so we can seal those holes and keep pressure on that plate. I'll pull that later. I forgot to do it while I had gloves on, so next time I'll pull that apart, and I'll video it before posting this anyway. So 2 things, one-way valves required on those ends of those pumps. This pump seems to run much faster than that pump for some reason. So it probably helps to have the pumps at the same type of, but I couldn't get 2 of the same, exactly same type, so that I'd imagine the wiring coils are different in each of those motors. They're different Toyota models. This one's got nice little clipping things. That's got little small clips I had to put soldering on. So one-way valve will probably eliminate that need to have those pumping at the same volume, because it should fill up and then just stay full, providing it doesn't cross over quickly. I'd say that membrane may have a break in it, because the little Tic Tac containers I used before with the separator, they sort of held the liquid in both sides quite well. So I'll revisit it, because we didn't lose our electrolyte. It just got a bit carbony. It won't hurt though. Alright, till next time. pH paper has turned a reddish colour. So it's not that one. So it's off the scale in alkalinity maybe. Down there somewhere. Okay, I popped the cell apart. The membrane was ripped. So I think when I lit the end, when I had hydrogen going through there, it blew back into there and tore that to shreds. I can't see the water doing that, because they hold up pretty well with the cellulose acetate. And another thing, the silicone, I must have squeezed it up too tight. See, it's squirted off. It didn't stick onto that at all. So that's another thing. And what I might do, see how I got the gap between the bolts and the end flange there? I'll cut that stainless steel piece so it fits on the inside. And then that way we don't have to drill through stainless anymore with the cell. I'll have to make slits come up through here, so we got contacts. I'll probably run 2 contacts through those 2 holes, and that will be enough. And then I can bolt it, and we should be sealed. This one here is sort of coming apart. Yeah. Broke, that pad just broke. Wasn't quite bonded like that one. So probably enough carbon on there to do another test, minus these little bits. But the it soaked the carbon up well. That's totally wet still. It's the next day. I could try making some other ones with clay this time, like in Robert Murray Smith's demo video. So I'll set that up sometime this week. And oh yeah, and I ordered some one-way valves. They're a bit dear, $7.25 each. but that should hold the liquid in there and not backfeed through the pump. I think if it was a normal pump, not a windscreen wiper one, they don't have, the rotor doesn't look like a real rotor. Don't know what's inside. Can't see any fins through that big hole, so I think they're a different style. So I'll put the one-way valve on, and that should keep the liquid in the container or in the chambers there, and we'll be able to charge and then pulse the motors every few seconds just to refresh the electrolyte. That's the theory, so we'll give it a go, and this time I can bolt it, which it needs to be bolted because it did leak a bit. And I'll try some different silicon this time, or I might even make some gaskets. To cut one side, and I need to put another plate at the back of it. I'm going to try some cotton coated in cellulose acetate. This has already been coated. I may give it another coat tomorrow, and I've noticed this plastic acrylic, see all those little marks going through there? If you can see it in the sun, well, it looks like the zinc bromide destroys the structure. Look, it's just like crumbling. So I'm going to have to find something to replace these with. The breadboard doesn't get affected, so I'm going to have to find a thin piece of this stuff about that thick. Unforeseen. That side, this one's held up a bit better. I think it did leak there though, because you can see it. It's going to probably crumble by a week's time and destroy itself. And in the cell there, we must have started charging. There's like a little bit of residue building up on both of them. See that stuff? The plates are clean before that electrolyte went in there. So it may have worked if the liquid held. So this will be stronger. We won't be able to bust through it. It should have a microporous film due to the cellulose acetate with brake fluid in it. We'll need a wash to wash out the brake fluid. And it should be a microporous membrane. We'll see. Okay, I trimmed off this plate so it no longer goes through the bolt holes, so I can use the bolts. It's gone a funny colour after that first run. Same with the other plate. I'm going to leave that one because no need. One side's okay. I'm using a bit of pure cotton. It's a work shirt, old one, as the membrane. I've got it siliconed in there at the moment. It's got 2 coats of cellulose acetate on both sides. It's quite taut. It should have enough flexibility when I squish it together with the bolts. It should seal up pretty well. I've got a test sample there which was in some zinc bromide. It hasn't dissolved and the coating's alright, and it's still holding up. You can sort of see the coating. I stopped about there. You can see the difference in colour. So it doesn't dissolve. The electrolyte's acidic, not alkaline. Like I said, I had to scale up. I don't know why I said that when I said it was alkaline, but it's at the other end of the scale. So I'm still waiting on 2 one-way valves. And when I get that, I can test it. Everything else is holding up. These tubs are resistant to it. The pumps seem to be resistant, and also the hoses, so that's a good thing. This stuff isn't attacked by the zinc sulfate. The acrylic stuff is, but I'm going to use that anyway because it may not work anyway. Before I source another bit of plastic, I'll just use that. That should be alright for a day. That one's still holding up, but it's gone brittle. You can like just crush it. It crumbles with your fingers. So I'll use them for now. I'll coat them in silicone and glue them all together later on. So hopefully sometime this week the one-way valves come. Then we can give it another test. The vinegar bottle's holding the zinc bromide's holding up. It's not eating away. Got it in one of those Pyrex dishes as well, just in case it does eat through it, because I don't have much of the zinc bromide left and don't want to waste it. I also want to make one of those cells Robert Murray Smith made with the zinc bromide after this experiment. I cleaned these pads, but some of them are pretty eaten away. That one was covered in zinc, but you can see the iron chloride does attack the stainless eventually, plus the zinc plating on that one. I sort of ground it away. I'll make that the positive side. Alright, small update. I'll get back when I've got the one-way valves. Okay, back 4 weeks later. I modified this negative plate. I chopped out the holes, so now it's insulated from this plate and I can use the bolts. I have 2 one-way valves on the inputs, so we'll be able to fill the cell and it should hold its level now without flooding back into the chambers. The aluminium, apparently by Google, zinc bromide reacts with aluminium to form aluminium bromide and zinc metal, but I put some down here, around about here. There's a sort of stain, but I can't see much of a reaction, so it's only 1 mole solution of zinc bromide. And see, nothing's going on there, so I think those one-way valves will be alright for a short duration test, and then I can flush them out. So I'll put in 500 mils of zinc bromide in each tank, because I've only got 1 litre. And hopefully the cell doesn't leak. It's been siliconed up. I'm using a piece of 100% cotton from an old t-shirt as the membranes. It was coated twice in cellulose acetate, so it might take a while. Zinc bromide doesn't eat the cotton membrane wherever I chuck that piece. I had a test sample and it's still fine. Hasn't even eaten away at the cellulose acetate on it, so it's looking good. I have the speed controller, got a multimeter set up on the positive of the motors to monitor the amperage. Gonna use a dead sort of battery. It's not that great. Got a charger to keep the charge going and 12 volts. So I'll fill the tanks and I'll get back. Because the module always, for some reason, is on at default every time you turn the power on. So we have actually got some voltage this time. So the one-way valves are holding. I've got no charge going through it yet. I just need to hook up the negative. We'll fill the chambers. I have some plastic around there so I don't get covered in electrolyte if something happens. We're at 43% for the motors. Might have to increase that. Here's one. The second chamber's full now. We're at 0.08 volts with no charge going through the cell. Okay, we seem to have electrolyte in both. The containers that one's about there. So we don't have a break now. The membrane might take a bit to go. So I'll start the data logger. Well, first I'll connect the negative lead. Okay, we have 1.4 volts going through the system, where we could increase that. There we can't, because it's like acting as a short circuit. The voltage isn't going up. Alright, we're at 2 volts, 800 milliamps. I'll commence data logging. We'll try it with the pumps running first. The lead acid battery is, this one here bubbles. So it's pretty, I think those seals in there are knackered. Well, we got a, I think maybe it's leaked. Yeah, I got a slight leak, I just saw a drip. But that won't matter. So the pumps are working, I can smell this battery, it's overkill. We'll check the voltage on the the milliamps. Oh, we're 1 amp. No, we're not. We're about... Okay, we're still drawing 800 milliamps. Or 800 milliamps, get it right. We don't have any colour changing yet. This is the negative tank. And the other one's the positive. The negative side's got the broken electrode where it fell off. So it's not too leaky. I think it's leaking out of the membrane area. Maybe. Voltage dropped a bit. Milliamps are staying. Oh, they are dropping. Now I'm not sure if I should keep the pumps running or turn the pump off and hold the liquid in the chamber and charge and then dump it. I'll keep them running for now, as long as they're not overheating. Alright, I'll be back in a few minutes. I'll keep an eye on the charge dropping. Oh, it's increasing there. Oh, it's fluctuating actually. Yeah, currently set on 2 volts. If I adjust this, we don't get any more. So the little power supply is maxed out. I think we just increased the amperage a little bit maybe. Okay, I'll be back. Negative hookup on there, now one's still on there, won't matter. We're doing 1 amp now at 50%. We have a flow there and a flow on the other side. You can see that shooting up the side. And we spiked when I stopped the pumps, so we may have to just turn the pumps off and let them sit there and charge up for a bit, but it's only been, where's the timeline, 6 minutes. Alright, I'll get back. Okay, I just turned the pumps off, so we had a spike in voltage and a slight spike in milliamps. I'm sort of bleeding back down. So I don't know how much actually electrolyte's in the chamber. So we'll let that sit for a while and then we'll give it a burst to flush the charged liquid through to the tanks. We're at 900 milliamps, so give it a burst. We don't have any colour change yet. We're consuming 1.3 amps on the motors. We're at 11 minutes. We've got probably about a 2% chance this may work. I'm surprised it actually has a voltage going across it now. Seems pretty beefy with 800 milliamps. It is a sort of large cell. I'll give it another burst. See the power consumption when we drop it down. Oh yeah, we're lowering our milliamps. I'm a bit afraid the motors might get a bit warm. Right, we're 100 milliamps. Got like a trickle. Both chambers are full by looking at those hoses. There's no air in them. Tanks are around about the same level, so that's good. Dripping sort of stopped. Still no colour change in any of the tanks. And the vinegar bottle holds the electrolyte quite well. I had the vinegar bottle sitting in the Pyrex dish just in case it did rupture, but it seems to be good. It's only acrylic. I still have the 2 pieces of acrylic in there, well, they're 2 new pieces. Probably be alright for this test, and eventually it will corrode away. That one sort of held its integrity, but it's very brittle. You can fracture it quite easy. The other one I sort of broke apart. See how well it broke apart. Okay, I stopped the pumps around about 25 minutes nearly. Yeah, it's been around about 15 minutes. We slowly went down in milliamps, so they're creeping back up again, so I'll give it a purge. And if you can see, that's the negative one. We should see some liquid. Yep, so we're shooting up. I'm not sure if the light is doing it, but that tank there, the positive tank, is looking a bit greener than that other tank at the far end, as you can see. So the cell may need to have solenoids at the bottom. Fill the tank, shut the solenoids off, let it sit there for about 10-15 minutes charging, then recycle it perhaps, because I was thinking maybe the zinc bromide's a bit too heavy to come back up. So we have a voltage drop when we pump the liquid. Definitely looks greener than the other side. Okay, I'll give it another 10 minutes with no filtering. For some reason the negative one drains out, the positive one sits full. It's probably because that's the side what's leaking maybe. It's not dripping that much, as you can see. Oh, it's a bit blurry. Well, the little drops in there. It's been 30 minutes and that's all we've dropped out. Oh, positive tank's just drained out now. We're down to 875 milliamps. We'll keep charging, see what happens. Okay, checking the temperature of the cell. 18 degrees. 17. Bit of wood's 28, so it's quite cool. We're not heating up, we're still consuming 868 milliamps, so we're dropping a bit. There's definitely a colour change now in the 2 tanks. As to what, maybe it's the material, but it should be colour changed in both if it's the material. And the test sample didn't leach out any blue because it's a piece of blue cotton. I've been letting it sit around and then purging it, then sit around and purging. It's been nearly an hour all up. It's going to be a long day. We're going to have a 50 milliamp load, so I'm not sure if it's going to actually do anything, so we'll find out later. I'll wait for a really major colour change in both tanks maybe. It's been an hour and 12 minutes. The tanks are definitely getting different colours, and now we're holding liquid right to the top of the tubes. It's not back draining, so maybe the membrane's swelling up and taking up the slack, and it's sealing itself. The temperature, I just purged it then, 18, 19, a little bit of an increase in temperature. Starting to drip near those little bolts sticking out there, so bad design. Okay, time to purge the tank again. We're not getting high voltage spikes anymore. I think it's due because the tanks are still full. So I'll purge it for a bit. We're down to 850 milliamps. Voltage is dropping for some reason. I'm starting to get a major colour change. A little bit of leakage down the bottom, not too bad. As for when it discharges, I'm not sure what's going to happen there. We might still have to do the purging every 20 minutes or 10 minutes. Oh, some voltage went up slightly with the purging. That should be enough. Alright, I'll keep updating. It's been an hour and 50 minutes. Voltage is still going down a bit, and milliamps is now 830 milliamps. Not sure if you can see it, but on the side with the black alligator clip is the negative side. There's some bubbles forming. They're not that fast coming out. There's a larger one every now and then, see it? Where it builds up. And as yet I haven't seen anything like that happening in the positive side tube. Oh yes, I've just seen some gas then. Okay, so we've been charging for 3.5 hours. I've been coming out every 10 minutes, and I think it's mainly where those spikes are, and they started getting less and less to siphon the water, pump the water through. So we definitely have colour change. Not sure how much darker that's going to get, so I'll disconnect the charge, connect it to the data logger and get back. Have the data logger connected, and we're at 0.8 volts. We've got 50 milliamps set, and stop the monitoring. And I'm not going to put a cutoff voltage because it may drop. Alright, we're holding 0.5 volts at 50 milliamps on the cell. I'll just turn on the pump. Pump's at 25%. Stop the pump. I'm not sure if we need to do a discharge with the pump running all the time. I don't think we had a major voltage drop by turning the pump off, by the looks of the graph. Voltage is dropping pretty quickly. I'll try a pump again. So it may not be doing much. I'll increase the pump flow, see what happens. Nothing really in the curve happened then. Showing bubbles. So I'm not sure if it actually worked or not worked. Oh, we've got a major spike there. I'll slow the pump down. Or I'll turn the pump off. Oh yeah, okay, pumping does matter. So we had a raise once I stopped the pump. I'll turn the pump on again and slow it down. Okay, we're at 23%. That's how fast we're going. I think we had another increase in power. And it seems to hold at that voltage. So we'll keep it cycling. Hopefully I'll keep an eye on the pumps. I'll take a measurement of their temperature. Can't get in there with one hand. I'll get back later. Okay, it's been around about 20 minutes without a purging of the pumps, so I'll try that now. So we're at 0.18 volts. Okay, purging. It's going to take a bit because I got it on 20%. Here it comes. Okay, we shot up in voltage, so purging has an effect. Refreshing the electrolyte. I might put the pump up a little bit. There we go. So we only gain a little bit of voltage. But we're back to 0.2 volts. Oh, we was. Okay, I'll stop the purging and let it go for another 20 minutes or so. So we're at 0.2 volts. Okay, I started pumping some electrolyte through the system and we just hit 0.2 again. It sort of slipped down and kinked the inlet there at the bottom. So I pumped it up with something. Didn't notice that before. I was increasing the pump speed and no water flow was coming. So I'll come back in about 20 minutes and I'll turn the pump off and I'll be back in 20. So far we're like 61 milliamp hours, 13 milliwatt hours. We're very low on voltage. cycle it through for a little bit. The voltage is raising. I'll cycle it for a bit and get back in about 5 or 10. Okay, the pumps have been running for about 5 minutes, and we've increased our voltage with the pumps running at 35%. So I'll increase it to 45. Oh no, 40, and see if we increase. Oh, go the other way. Okay, we're at 40%, and we have got an increase slightly. And we're holding steady at 0.5 volts now. I don't know how long those windscreen wiper motors are like running for. So electrolyte should try to keep them cool maybe. And we just went up 0.003. Wonder if we can break the 0.5 barrier. No, we're holding strong there by the looks of it. I'll leave that for a while and check. I've adjusted the power levels of the pumps to 45%, and we're still increasing slowly. We're at 0.52 volts, which leads to question, because of the flow rates are different on charge to discharge, you'd have to have a bank of discharging cells and a bank of charging cells maybe, which would sort of work, and 4 pumps instead of 2 pumps. Uh-oh. Maybe it's too much for the pumps, I just heard noise change. And we increased again in voltage. We're sitting at 73 milliamp hours and 18 milliwatt hours, 1 hour and 27 minutes. Hopefully the pumps are strong enough to hold this and do that. I'll see if I can check. Oh no, I won't do that. I'm holding the lead apart there with the thermometer, thermal reader. I don't know how long I can sustain 40% power on the pumps. They're at 46 degrees now, and we've gone up to 0.532 volts. And stable. But it's a pretty big cell for a little bit of power. 2 hours of runtime. We've creeped up to 0.541 and holding there now for a while. And we're at 100 milliamp hours and 33 milliwatt. But most of that milliwatt hours was based on a lower 0.2. That tank seems to be a bit lower than the other tank for some reason. And I've taken the thing off and put a bag there. It's getting humid. I got some crust forming on the other tank at the top there, see it? Maybe like a zinc oxide or something. Yeah, we're at 40%. We're about 30 degrees, 23 there. We're creeping up to 60 degrees on that motor, and 52 on that one, 51. So I think they can still go. We can get them a bit hotter. They'll start cooling down once it gets a bit later. So still not sure about it. Seems to be holding its voltage now, pumping the liquid through at that rate. The flow rate's like that. Maybe getting paler at the bottom. I can see sort of, there's a darker up the top and a lighter at the bottom on that tank. Could be just a shadow though. Okay, we're at 3 hours and 27-minute run time, still holding 0.494 volts. Milliamp hours 173 and 70 milliwatt hours. I've had the motors running for an hour and a half and they seem to be holding up to 40% power. Well, I think we're leaking electrolyte into the other tub slightly. We'll keep it going. Later on, when it gets a bit later, I'll adjust the load and see if it does 100 milliamps. That will end the experiment sort of faster. Okay, that tub there is draining into the other one and mixing back. So you probably don't have much time. I've got it on an angle. So we've been running for 4 hours and 30 minutes. 225 milliamp hours and 95 milliwatt hours, sorry. And I'll just adjust to 100 milliamp load for a while, see what happens. Okay, we're doing 100 milliamps. We drop down to 0.365 or we're dropping faster. Alright, might finish it off with this run like this because we're really running out of electrolyte. Taking the motors down to 35%. Cell's been running for 6 hours. It's at 0.05 volts and we're doing 100 milliamps. It's only made 375 milliamp hours, 137 milliwatt hours. So we'll back it off to 50 milliamps again. And see if the voltage increased slightly. We'll check the pumps. The tank's running out now. It's draining into the other one for some reason and going back to the normal colour. I've got it on an angle there. So we'll slow the pump down. It's at 35% now. And we've got a further rise in our voltage. We'll take it to 10 milliamps. Okay, we're at 10 milliamps. We don't have much of a voltage increase. The motor's temperatures are dropping. They're 48, 46, 49 degrees and 41. This one here seems to pump faster than that one. That's going back to its muddy watercolour. We'll see the bounce back with no load. It won't be probably much. It's got a slow increase. And stopping the pumps. I think the liquid's still in there. Yeah, both chambers are still full. I reckon if the pumps were pumping at the same rate, the chambers would stay about the same in form, and the voltage bounce back. I might leave it for a bit and watch the voltage recovery. Been running idle with no load for 10 minutes with the pumps running at 40%. I set the monitor and it slowly went up. I've set 300 milliamps, but I don't think it will do it. So here we go. Oh yeah, it's running 300 milliamps but dropping rapidly. That's zero voltage. The meter doesn't go down any lower. And it's finding it hard to keep 300 milliamps. The next test I might put the buck converter on it and see what we can get out of it. See if we can boost the voltage. I really need some more electrolyte. I'll think about it. And 2 pumps of the same type maybe. It's still holding in there. Slowly running out. Oh well, I'll post the video. And thanks for watching.